Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 20 for the March daily Leetcode challenge, and this is the hard question. And let me tell you this is going to be a FAANG level interview question. And again, I will repeat the same. I will not like go through each and every word mentioned here. I expect you to do that. Always the question link will be in the description. And even if you know, like for example, this is day 20 of the March daily Leetcode challenge. So you can very well go in the Leetcode webpage and search that part, right? So it's always possible for you to do that. And always if you're seeing the video, always the question link is in the description. So I'm not going to read everything here, what I've highlighted currently. I expect you to do the same. And then after you have given an attempt, or at least after you understood the question, then you should continue from here. Okay, that is the expectation that I want to set to, because see, our aim is to target those kind of companies where which is dream of money. Okay, we cannot be reading everybody here and I am explaining everything. So this kind of a spoon feeding that I will. Okay, so my aim will be to make the video as short as possible. In that I only deliver the content, okay, which is required, the ideas and the logic building steps. So in this question, basically, this is first of all a very good question, because there are so many things involved here. There is a graph kind of concept involved here. There is a concept of disjoint set union involved here. Okay, which is also called union find, and there are multiple other things around here. Okay, and obviously the bit manipulation part also, because we are using the bitwise and operators. Okay, so just let me summarize what we have seen. See, in this case what we are given is, you are basically given a graph. Okay, in the graph all the edges are going to be bidirectional. Okay, because there is no it's not a directed graph, it's an undirected graph. So edges are going to be bidirectional, and obviously there is a weight here. Okay, each of the edges have a weight. Okay, so this is not like all the edges are, like, see, we do BFS and DFS kind of algorithms when the graphs do not have a weight. Okay, as simple as that. So we find the nearest and all that. Okay, but when they have a weight, the solution is slightly different in that case. Okay, because BFS and DFS, they are traversal algorithms. In this case, the edges have a weight. So when they have a weight, it becomes difficult. See, then we cannot say, okay, this one, 0 and 1, or 0 and 2, like which one is going to be near and all that. Okay, so when they have edges, we have to respect those edges. Okay, as simple as that. And similarly, in this case, what we are given is, see, we are given the edges. Okay, this means, see, there is an edge from 0 towards 1. Okay, and the weight of the edge is 7, as you can see here, 0 to 1, this edge, and the weight of that is 7. Okay, and so on. Similarly, we are given some queries. So what they're asking is, see, they're defining a term called cost. Okay, they're defining a term called cost. So what is this cost? They're telling cost means, uh, for example, say there are two nodes u and v. Okay, there are two nodes u and v. So in order to reach from u towards v, okay, so there will be multiple paths. We can take any path the way we want. Okay, we can take any path like that. Okay, but the idea here is, the cost is going to be the bitwise end of the various weights that are involved in this path. Okay, remember, I'm talking about weights, I'm not talking about the number u or v. Okay, when we go from u to v, we may take some path. Okay, we can take any path we want, but the cost of that particular path is going to be the bitwise and of the weights that are involved. Okay, the bitwise and of the weights that are involved. Okay, something like this. Okay, as simple as that. Okay, and is the bitwise and operator. So now they are saying, like, for each query, for example, see, this is the query 0 3, so 0 is here. Okay, 3 is here. What they're asking is, you can take any path the way you want from 0 towards 3 if they're connected. If they're not connected, obviously the answer is -1. There is another important point. If two nodes are not connected and the query is asking you to find the cost between them, obviously you have to say -1. Okay, because something which is not connected cannot be, we cannot reach from that node to another node. Okay, as simple as that. Now let us say if they're connected, you can take any path that you want, and you have to return the minimum cost. Okay, so what is the minimum cost? Minimum cost refers to, you can take any path that you want, but the cost of the path, as I mentioned, is going to be the bitwise end of the various bits that we witness when going from the first point, that is the source, towards the target. Okay, so among all such paths, which is the minimum way that you have written? Okay, so that is the question. Many of you will feel, see, when I say the minimum path and shortest path, all that, many of you will think of various algorithms that we have in graphs. But let me tell you that this question is not about graph algorithms. You need not know any graph algorithm to solve this question. Let me be very frank here. Okay, you did not know any algorithm to solve this question. Okay, why I'm saying like that? See, there comes the part of understanding the question properly. Okay, this step is very important whenever you're going to target a FAANG level interview. Okay, because see here, obviously, everyone knows, right? Wherever we think of the shortest path, we have algorithms in graph. But the point is, this is not required, because here the path, like, I mean, see, the shortest path, when we say, we are referring to the path, here we are referring to the minimum cost. Okay, because the cost is not the simple sum of the weights here. So this case is, you cannot achieve this kind of solutions with a typical algorithm in graphs that we have for shortest path. Okay, as simple as that. So I'm making this point very clear. Please try to understand how the things are becoming different here. Okay, from shortest path, here we are trying to achieve minimum cost. Okay, since cost is something like this, okay, which is not linearly dependent on each of the weights. See, if it is like a sum of weights or a difference of weights, something like that, then yeah, we can think of such a solution. Okay, like the graph program that we have for minimum path and all that. Okay, but in this case, it is not like that. It is the AND operator. So you have to think of a solution which is very specific to this AND operator. Now let us analyze what is happening. See, for example, Let us say I want to go from 0 to 3. Now, what are the various paths available? See, but first thing again, I will say, see here, there is no constraint on how many times you can, go through edge, or how many times you go through a node. There is no constraint like that. You can go anytime, as many times as you want. Okay. Now, some of you will ask me, okay, that there could be a case where we have the, circle. Okay. That is, we have, a circular graph. Okay. Where the graphs, where the nodes are connected to each other and all that. Okay. See, the idea here is, if you see the AND operator, no, see, AND of a single number with itself is always one. Okay. AND of a single number with itself is one. That means, okay, that means even if you traverse that weight n number of times, still the result will remain the same. Okay, still the AND operation result will remain the same. Okay, that is the basic idea of AND. Okay, so again I will repeat. See, if you do AND of two numbers, let us say 7 and 1. Okay, if you do AND of two numbers 7 and 1, either the answer will decrease or it will remain the same. Okay, remember, the answer will never increase. Okay, AND operator will never increase your answer. The result of the AND operator will never increase. Okay, as simple as that. So let us say A and B are the numbers. I am doing AND, so the answer will never be greater than a comma b. Okay, so whichever is the, see, AND operator will never increase the values. Please start to understand this part. Okay, so whichever set bits are there, either they will remain or even some of them will, become unset. Okay, that is the basic idea with which we should be proceeding. So the idea here is very simple. We have to take all possible cases and then we have to find the minimum. Okay, now if you see for this particular example, 0 to 3, the answer they are saying is 1. Okay, how 1 is coming, let us first of all understand that from 0 we are going to 1, so it is 7 currently. Okay, from 1 we are going to 3. Okay, we could have done that, the answer would have remained 7 in that case, but they are writing answer is 1. Why that is happening? See, from 0 to 7 you are going, from 1 to 2 you have to go. Okay, so the now the path, that is the, if you see the cost will from 0 to 1 and 1 to 2 will be the AND operator, the AND operation of 7 and 1. Okay, bitwise AND of 7 and 1. If you do a bitwise AND of 7 and 1, what you are going to get, you are going to get 1. Okay, because 7 has 3 ones. Okay, if you see the, binary of 7, it is going to be 0 1 1 1. Okay, similarly the number 1 has a binary of 0 0 0 1. Okay, if you do AND of them, you are going to get 1. Okay, so the AND of 7 and 1 is going to give you 1. Okay, now we have to go back now. Okay, 2 to 1. Okay, obviously 1 is there, you are doing AND with 1, it will remain 1 only. Okay, simple as that. AND of the operator with itself is 1. Okay, now then we are going towards 3. Okay, now it will be again AND of 1 and 7. Okay, because from 0 to 2 we have a, the overall is 1. From there we are going to 3, so it is going to be 1 and 7 and. Okay, so if you do AND of 1 and 7, you are going to get 1 again. Okay, as simple as that. So the final answer that we are going to get is 1. Okay, now can you tell me one thing? See, now I will ask you a very simple question. We know that the AND of 0 and 3 is 1. Okay, I have shown you the calculation why it is 1. Okay, now can I ask you what is the short, that is what is the minimum cost between 0 and 1? Okay, my question is very simple. I want the minimum cost between 0 and 1. Can you tell me that? Similarly, can you tell me the minimum cost between 1 and 2? Similarly, the minimum cost between 1 and 3. So the idea is going to be the minimum cost among any two nodes. Okay, any two nodes in this particular component, that is among, see, 0 1 2 3. Okay, among them any, edge let us see in this query, see, as ing. So if you have a query between any two nodes of this particular component, that is between 0 1 2 and 3, always the answer is going to be 1. Okay, why it is like that? See, it's very simple, because see, in this case what you are saying is there are only three weights. Okay, 7 7 and 1. Okay, if you take AND of all of them, you're going to get 1. Okay, that is why if there is any query which has, edges, which has nodes between this particular component, that is between 0 1 2 and 3, always the answer is going to be 1. So basically, I'm telling you that the answer is going to be fixed, whatever be the query. If the query has the source and target between this component, that is between 0 1 2 and 3, if the source and target lies between these four numbers, then the answer is always going to be 1 in the example number 1. Okay, that is the basic idea. So the question, now basically the thing is going towards the disjoint set union, that is we have to form a component now. Okay, that is we have to form a union now. So this, the answer is going to depend on which union the source and target belong to. Okay, as simple as that. For example, see here, 4 is a separate. Okay, it's a separate component, it's a separate, disjoint set. Similarly, 0 1 2 and 3 are basically separate, component, or basically separate, disjoint set union. Okay, they'll be separate disjoint set. So now, depending on where the source and target is, first of all, see if the source belongs to different component and the target belongs to different component, they're not, joined. For example, 3, between 3 and 4, if you see, there is no connection. Okay, that is 3 belongs to a different component and 4 belongs to a different component. So the answer is going to minus 4. Okay, because there is no connection between these two, we cannot find. See, there is no path existing. Because no path exists, we cannot find, the cost. Okay, see, come. The cost will come to the picture only when there is a path. If there is no path, obviously there cannot be a cost, so we cannot find the minimum cost. In that case, we have to return minus 1. Okay, they have clearly mentioned it here that we have to return minus 1 if there is no path possible. Okay, if there is no such work possible. So the point is going to be very clear now. If you are, see, the query is, asking you to find the path between two nodes which belong to different components, the answer is going to be minus 1. If they are asking you to, find the cost where the source and target belong to the same component, then the answer is fixed. Okay, for example, if let us say I am adding two more queries. Okay, let us say 0 to 2. Okay, similarly 0 to 1, similarly between 1 to 2, and similarly between 1 to 0. Okay, anything I can add. Okay, between these four numbers I can give you the combination of any two. Always the answer will be 1 only. Okay, the idea is very simple. If you do AND of 7 and 7 and 1, okay, 7 and 7 and 1, if you do the bitwise AND, I'm saying always the answer will be 1. That's why the cost will always be 1. Okay, that is C. That is the minimum value that we can get. Okay, because of AND. Okay, if there is any value greater than that, it's always possible to reduce it by doing another AND. Okay, as simple as that. Now, see, as I mentioned, the AND operator, if the values are same, the result is going to be same. Okay, for example, the idea here is, see, I traverse this edge. Okay, that is 0 to 1. If I travel 7 times, 10 times, 9 times, still the AND operation will give you the same result only. Okay, as simple as that. So idea here is, if I go from 0 to 1, and then 1 to 3, and then back 3 to 1, and any path that you take, the way you want to do that, and still the answer will remain the same, as long as the component that you have, for example, 771. Okay, if you take them one at least once and do the AND operation, you are still going to get the same answer. So that was the basic idea. With this, we'll start the solution. It is going to be disjoint set union solution. Before that, I will again do a tracing so that you understand the whole aspect of this question. Okay. See, always for this kind of questions, I always focus more on the logic building step, because if you understand the logic, now you will appreciate the solution why it is happening like that. Okay, and believe in the solution that I've given. It's going to be very very efficient, because I've given you this whole component basically. See, I've given you whole this DSU class separately. What you can do is save this in your OneNote or wherever you want. You can save it here, and any other question when it comes to a DSU question, you can always use it. Basically, DSU means the disjoint set union. In LeetCode, they also call it as a union find. Okay, so this is the basically class. You can save this class basically. You can reuse it multiple times. Okay, wherever you want. Okay, it's a very full-fledged class. Everything is handled here. Okay, as simple as that. Okay, I've kept it separately, and I'm making use of it in the real solution. Okay, first of all, let me show you the basic tracing of a good sample case. So this sample case is not among the examples. I've taken it separately, but yeah, this is a very efficient one. See, so as you can see, the number of nodes. Okay, now let me write it here. The nodes are going to be between 0 to 4. Okay, the nodes are going to be from 0 to 4. Okay, 0 to 4. Okay, as simple as that. Okay, 0 1 2 3. Okay, 0 to 3, right? So these are the nodes going between 0 to 3. Okay, so there are basically four nodes. Just a second. Yeah, there are going to be four nodes, right? Now the first edge is between 3 and 1. Okay, 3, 1 and 2. Okay, 2 is the weight. 3 and 1 are the either the nodes from which there is edge, between which there is edge. Okay, 3, 1 and 2. So what we'll do is, we will try to see initially all the fours. Okay, 0 1 2 and 3. Okay, there are four nodes. Initially, for all four of them, they will be separate sets. They will be separate disjoint sets. When there is a edge, we will combine the two sets and make it one set. Okay, so in this case, we are combining 3 and 1. Okay, so what we'll do, see, the leader means, for a set, who is the leader. Okay, in this case, if you see, I'm going through 1 and 3. Okay, so 1 and 3, after, see, since I have added a edge between 1 and 3, so for both of them the leader will be now the same. Okay, any one of them will be the leader. Either it could be 1 or it could be 3, but for both of them there will be single leader. So in this case, if you see, for the index 1, the leader is 1. Similarly, for the index number 3, the index is the leader is 1. Okay, so for both of them, now the leader is same. Okay, and for this particular set as of now, okay, this particular disjoint union as of now, the distance possible, okay, that is the distance possible is 2. Okay, what I'm doing, I'm taking the number 2 as it is, and I'm writing it here. Okay, as simple as that. Okay, because this is the first two members of the set, so I'm taking the value as it is, and I'm writing it here. Okay, so if we try to keep if we try if the query comes between any two edges of this particular component, the answer is going to be 2 now. So fine. So if you see, this is how the graph is going to look like. There is a this is acting as a single component, because 1 and 3 are part of a single component now. 2 is a separate component. 0 is a separate component. Okay, these are all the nodes that we have as of now. Okay, now comes the second edge. The second is between 2 and 0, and the weight is 6. Okay, so edges 2, 0, and the weight is 6. So what we'll do now is, see, 2 and 0 as of now a separate component. Now they will be part of a single component. Okay, and there will be a single leader for them. So if you see the number 0, okay, and the number 2, okay, so for both of them, now the leader is going to be 0. Okay, so 0 is going to be the leader for both 0 and 2. Okay, and if you see, since the weight is 6, so we are adding 6 here directly. Okay, as simple as that. We are adding 6 here directly, right? Now if you see what is happening, this is how the graph is going to look like. 0 and 2 are part of a single component. 1 and 3 are part of a separate component. So if you talk about 1 and 3, the leader is going to be, in this case, 1. Okay, similarly, the leader for 0 and 2 is going to be 0. Okay, so if you talk about 0, the min cost, that is, if for this component, if there are source and target are, we have a query for which source and target are in this particular component, then the answer is going to be 6. Okay, for this particular component. And similarly, for this particular component, okay, if there is a query for which the source and target are in this particular component, then it is, you can guess, the answer for this case is going to be 2. Okay, the minimum cost in this case is going to be 2, because obviously there is a single edge as of now. There is no more edges, so obviously there is only single path possible, and the cost is 2 as of now. Okay, now comes the main part. Now we are going to create edge between these two components. So we are going to create edge between 3 and 0. Okay, 3 is part of this component, 0 is part of this component. Now between these two components we are going to create an edge. Okay, we are going to create an edge, and that edge is going to be of weight 1. Okay, now whole scenario will now change. See, now there are two components, but after adding this edge, everything will now come under a single component. Okay, please pay attention here, this is going to be a very important part. Now see what you are going to do is, now if you see, for both these components, see here this was separate component, here it is separate component. Now we are adding edge between 3 and 0. 3 is a part of this, 0 is a part of this. So after adding edge between 3 and 0, now all these will be part of a single component. But basically we are going to do a union of two disjoint unions, I mean union of two disjoint sets. Okay, so this is why this algorithm is called disjoint set union. Okay, so when I do that, if you see, now the leader for all four of them is going to be 0 only. Okay, see how this leader is defined, this is the algorithm behind that, I will tell you that. But see, don't bother about, see, I'm not saying there will be only minimum number of deciding on that. Okay, zero in this case is the minimum number among all of them, but that doesn't play a role here. The idea here is only one leader will be there. Okay, and in this case the leader is 0. Okay, how the leader is decided, don't pay too much attention to that part. There is an algorithm that will tell you how the leader is decided. Okay, as simple as that. But just remember, only one of them is going to be the leader. Now for all of them, as you can see, there is a single leader. Now the most important part is, for the leader, the index of the leader is 0. If you go to 0, the minimum cost is shown as 0. Okay, why it is 0, I will tell you that. See here for this particular component. Okay, for this particular component, the as of now the minimum cost is 6. Similarly, for this particular component, okay, 1 and 3, for 1 and 3 the minimum cost as of now is 2. Okay, now when I join them, what will happen is, we will have to do an AND of these two. Okay, 6 and 2, if you do, see, 6 basically can be written as 4 plus 2. Okay, okay, similarly 2 is written can be as 2. Okay, so when you do end of this, what will happen is, you are going to get the answer is 2. Okay, 6 and 2 will be giving you 2, because 6 is basically 0 double 1 0, and 2 is basically double 0 1 0. Okay, so when you do and, you will get only 2. Okay, that is 0 0 1 0. Okay, so the answer of 6 and 2 is going to be 2. Now when the 2 you are going to see, but the weight is 1, right? You have to also do and with the weight. Okay, so this 2, that is 6 and 2 and 1. If you do 6 and 2 and 1, the 1 is coming from here, 6 and 2 are coming from here. Okay, the two sets that we're going to join, for them also we have to do and the new weight that is getting added, for that also we have to do and. Okay, so 6 and 2 will be 1, and 1 and 1 will always be, see, 6 and 2 will be a 2, and 2 and 1 will become 0. Okay, 2 and 1, that is before n, will become 0. So here that's why we are adding 0. See, the leader is 0, and for the minimum cost of the leader is going to be 0. Okay, that is the reason why the final answer, that is, whenever you know any query that you put between these components, the answer is always going to give you 0. Okay, that is what I've shown in the last example also. See, the last example, if you see, that's what I've taken here. See, we have so many queries, but the answer for all of them is going to be 0. Okay, because all the connects are all the nodes are connected, all the four nodes are connected, and if you see the min answer possible, it is going to be 0 in this case. Okay, there are so many queries, if you see, there are so many combinations of the numbers they have given among those four, and for all of them the answer coming is 0. Okay, so this was the basic idea behind them. Okay, now let us see the solution. Okay, so see, I expect you to learn this design class. I will not go in details of this, because see, this thing you have to learn on your own. Okay, I will just give you the highlights of what is happening. See, we are creating a design class, we are just passing the number and tell us how many nodes are there. Okay, how many nodes are there in the graph. Initially all the nodes will be a leader of themselves, and all that. Okay, all the nodes will be leader of themselves. So we are setting the n, we're setting the size as 1 as of now. We are say representative means the leader. Okay, it basically means the leader. And similarly min cost, see, idea is for each component there is going to be a min cost. Okay, as simple as that. Initially it will be -1 for all of them, right? Now the find function basically tells you, it basically finds the leader of a component. Okay, see, a component can have multiple nodes. Okay, we'll just pass the node here. This node will belong to a component, and we need the leader of that component. Okay, so this function will return the leader of the component to which this node belongs. Okay, so what we are doing, if self dot leader, self dot representative of node is equal to node, that means the node is actually the leader of the whole group. Okay, in that case you have to node itself, otherwise what you have to do is, we'll have to do a recursive call. Okay, this is a recursive call. We are doing self representative of node is equal to self dot find of the next value. Okay, if you see, we are again calling this function, so it's a kind of recursion. So we are again calling this function. In this we are passing the current node representative. See, I will not take much time to explain how this works. See, you have to basically learn this algorithm. This is a DSU algorithm. You have to know this in order to solve this question. Okay, as simple as that. So go through it part, do a tracing, like make these two arrays and do the tracing. I'm sure you will get it how it works. Okay, this is easy, so I'm not spending much time on it. At last you have to run the representative. Okay, as simple as that. Now comes to the union part. See, union means basically when we are trying to join two disjoint sets, we have to do the union. Okay, so in that case what we do for each of the nodes. Okay, so see in this case this node belongs to component, this node belongs to different component. Okay, see, in this case we are finding the leader of both the components. Okay, if the leaders are the same, that means they already are part of the same component, we can't do anything. Okay, we are returning false. Otherwise we have to do the join. Okay, how to do the join is very simple. We will compare the sizes. If let us say the size of this particular component is high, that is, see, this component So this node belongs to component, this node belongs to separate component. If the size of this is high, what we'll do is we will like merge the other component to this. Okay. So what we'll do is self dot representative of node 2 is equal to node 1. Okay. And similarly, the size of the node 1 is equal to existing size plus the size of the node 2. Okay. Simple as that. Now this is something extra that I'm going to do here for this particular question. See, what we're doing is, if the node 2 doesn't have a min cost, okay, if the min cost not -1, see, initially everything will be -1, okay, see this part, everything will be -1 initially. But if this is not -1, what we have to do, we'll have to do the say self dot min cost of node 1 is equal to self dot min cost of node 1 and self dot min cost of node 2. Okay, we are basically doing and between these two. Okay, this I've shown you here also. See, at last, if you see what we are doing and of 6 and 2, because these two components are getting merged. Okay, as simple as that. So we are doing and of 6 and 2, and at last we are also doing and with 1, because 1 is a bit. That part I have yet to show you, but just for now, learn 6 and 2 will be do. We will do a bit by the end of these two. Okay, that is how this is happening. Okay, from this step it is happening. And similarly, the else condition exactly the reverse of it, where the node 1 component will be merged to the component represented by node 2. Okay, as simple as that. Okay, the else condition is there. Okay, finally returning true. So true and false, you can even ignore. That is not the basic idea behind this, but just learn how the things are working. Okay, this is the actual function that we are doing. Okay, so first of all, we are creating an object of the DSU class where we are passing the number of objects. Okay, so this is the object of the DSU class. Okay, now I'm going through each of the weights and edges. What I'm doing is, see, I am first of all doing a join between these two. Okay, and then I'm just checking if, yeah, the min cost is not -1. Then see, if the min cost is -1, see, after doing the join, there'll be leader for them. Okay, so what I'm doing is I'm find the leader of the node for I. Okay, I need to find the leader of the component to which I belongs. Okay, I'm finding the leader. This function will give me the leader. For the leader, I'm going and checking the min cost. If the min cost is -1, then the weight that we have currently, okay, I'm directly assigning the weight as it is. Otherwise, if the weight, if the min cost of the leader is not -1, then we have to do and. Okay, with the existing weight, we have to do and of it. Okay, as simple as that. That's why if you see in this answer, what is happening, 6 and 2 we did and at last we did and with 1 also. Okay, because 1 was the weight. Okay, so 6 and 2 and 1, if you do, we are going to get 0. Okay, as simple as that, right? From there we are doing this. Okay, we're doing and. Okay, so if it is -1, see, -1 is the initial value, remember that. Okay, -1 is not a weight as such, it's just a value for that 25 that nothing was assigned to it. Okay, if it is -1, I'll allow the value directly. If it is not -1, what was the existing value, with that you have to do and. Okay, as simple as that. After that, I'm printing this for your convenience. If you see, while submitting, you have to comment out this part. Okay, as simple as that, right? Once this follow up is done, that means we have processed all the nodes. Then we are ready to answer the queries. Okay, how to answer the queries? Very simple. Whenever the query comes, okay, what we have to do, we have to first check whether the two nodes with which, for which you have to find the cost, are the part of the same component. Okay, if they're part of the same component, we already have the answer. If they're not part of the same component, that means they belong to two components which are not joined, which are not which are not connected, that we have to return the answer as -1. Okay, so if the leader of the node I, that's if the leader of the component to which node I belongs, similarly if the leader of the component to which node J belongs, if they are the same, that means we know the answer for them. Okay, how to know the answer for them? Very simple. Okay, first of all, find what is the leader for that. See, first of all, both of these nodes belong to the same component. First of all, you need to know what is the leader of this component. Okay, so this particular function will give me the leader of the component. Okay, I will go to the, yeah, once I know the leader, I will go and find the min cost for that particular index. Okay, I will go and find the min cost for that particular index, and that is going to be the answer which I will be appending into my answer. Okay, if they are, see, if the leaders are not the same, that means they belong to components which are totally different, which are not join. There's no join between these two components. Then we have to return -4. Okay, in this case we saw, no, an example when we saw this, see, 4 belongs to totally different component which is not having any connection with the rest of the components. Okay, with the rest with the other component. Okay, that's why whenever 4 comes in the query, you have to return the answer as -1. Okay, as simple as that, right? So yeah, this was the question, and finally we written the answer. Okay, so this part you can comment it out. This is just for your understanding. So today I my aim is very clear. I want you to understand this whole picture. Okay, when I saw this question, okay, I like went through the discussions and I saw the idea that, okay, they are talking about, see, this solution, okay, is very specific to the AND operation. Okay, had this been an XOR operation, the solution would have been very different. Okay, in this case we know that, when, see, here the cost is totally dependent on the AND operator. For that reason, what we are doing is, since we know that, and if you're doing, let us say we have 5 values, are going to do AND between them. Okay, idea here is and will never increase the value. Okay, and will either maintain the value the same, or it will only reduce the value. Okay, that is the basic idea. That's why it's always better to do a and of whatever weights we have in a component, so that we know that what is the minimum value we are going to get. Okay, as simple as that. That was the basic idea. But for other operators, it would have changed. Okay, it would have changed definitely. So yeah, friend, that was all for this particular video. Okay, as you can see, I've taken multiple sample cases. I've submitted the same, and yeah, I've already submitted the solution and debugged. Okay, as you can see, this is clearing all the test cases. So yep, you can take this and see, before commenting out, just try to understand how it works. Okay, see the example, do a tracing. See, this is the kind of question where it's not just about solving. Okay, you have to trace it out. Okay, see, this kind of question, believe me, this is teaching you a lot of concepts. Okay, maybe to learn this concept you will need 3 to 4 problems. Okay, but in a single problem they're teaching you so much. So take your time, have 2 to 3 hours with you. If you're a beginner, then trace out everything what is happening and try to learn everything. Okay, believe me, this will teach you a lot. Maybe see for disjoint pattern, what I will advise you is maintain this code in at least, at least in your notes. If you're maintaining a note, maintain that. But yeah, this is a separate component where you can use in multiple solutions. Okay, I have actually done the same. You should be doing the same. Okay, take it and save it somewhere. Whenever a question comes on the DSU topic, you should use the same component. Okay, and obviously, whenever you're preparing for interview, you have to practice this. See, this is how you should be doing. Okay, see this kind of solutions. You have to basically, this is the where you have to slightly memorize the thing. Okay, you should be able to know how, what are the various functions we need in a disjoint function. Okay, in a disjoint class. Okay, if you know this part, then it's very easy for you to when the solution comes, you have to just identify whether there is a case application of DSU here or not. And if it is so, you have to write this class and you have to create object and you have to start using it. Okay, that's the basic idea. Okay, just see how it works. Try to understand this fact. Okay, and yeah, before going to the interview, you have to just revise it once. Okay, as simple as that. And this is the only part where you have to focus. Okay, because see, it's very, it's very deep actually. Let me tell you that what is happening when you are doing the joints, right? When you are doing the joints here, basically, this part is going to very playing a very important role. Okay, see, many of you will have a doubt in this part because how it works when we are doing the join. Okay, so what we are doing is for the one, if you see the leader. Okay, yeah, the leader of the node 2 is equal to now node 1. Okay, we are doing that, but how this is getting changed in the real area. Okay, that is how, but this is where basically this function comes into play. Okay, if you see at each step we are changing the representative of a node. Okay, we are changing the representative of a node. Okay, so initially let us say there are two different components. Okay, let me take you the example here itself. Okay, see, initially they were having separate. Okay, one for one, for one set, zero was the leader. For one set, the node number one was the leader. Okay, at last everything zero become the leader. How that is happening? Because of this particular function is happening. Okay, here basically we're recursively doing that at each step. Okay, whenever the value is being written, it is being changed here. Okay, it is being changed here. So what is the value written from this? This is being changed here. Because of that, at last everything will be showing the correct leader. Okay, simple as that. So yeah, often that was all for this particular video. This was slightly on the harder side, but my aim is very simple. See, this video is even for those who are beginner, at the same time, even for those who know the topics. Okay, so that's why I'm not going in too much deep, and at the same time I'm not going too much at the surface. I'm trying to cover everything. I'm giving you ideas for everything, so that even if you're new, you know what to do. Even if you're experienced, you know what to do. Okay, as simple as that. So take these things. Remember, in this, see, if this question comes in a FAANG level interview, first of all, do not just depend on the code. You have to do a dry run also within stipulated time. You have to do the dry run the way I have shown you. Right, you will have to do a dry run with a proper test case and show you how the solution works. Okay, your test case should cover most of the conditions that could happen. For example, in this case, see, this is how it is works. Okay, at the last step you see there were two components. Okay, 0 and 1. Okay, there are two components, 0, that is, yeah, two components. At last we are doing a join between these two components. Okay, so at last we have only one component. So your solution, your test case that you're taking should be able to show you this part. Okay, and how the solution is working for handling this case. Okay, as simple as that. So yeah, friend, that was all for this video. But yeah, my point is very simple. See, you cannot scratch from scratch. You can write this kind of solutions. You should be knowing the DSU point. Okay, you should be knowing what is DSU, and you should be knowing the basic class for it. And then when this question comes, you should have to just write this class, create object, and then start your coding. Okay, as simple as that. So this class should be separate. Okay, because the logic here is totally separate. Okay, it's not only for this question, even for all other questions also wherever this is applicable, we will use the same class. Okay, that is the basic idea. And the custom logic for this question is where we are adding in this particular function. Okay, all the custom logic for this code we are writing it here. Okay, as simple as that. See, often that was all for this particular video. If you talk about the time complexity, see, for every area we are going through once. Okay, that is, yeah, we are going through this array once. Okay, we are going through the query array once, and obviously if you see, we are the number n also, we are creating multiple arrays of n. Okay, so if you see the range of n, we are writing here as it is range of n. So that obviously this follow for the range of n also. Okay, so it is on overall, it is going to be O of n plus number length of this and the number length of this. Okay, this was going to be the time complexity. Okay, and one more thing that you will ask me, see, here there is so much recursion happening, so obviously there will be some time going in this also. But see, that is where the theory comes into play. Theoretically, okay, the way it is defined, okay, theoretically it is supposed to be a O of constant. Okay, the way the leaders are changed, the way the leaders are updated, it is going to be constant. Why that is so, I expect you to go and read that out, but it is constant. Okay, theoretically it is going to be constant. Okay, the later updation part and the new later arrival and the merge part, the union part, all those things will take constant time. Okay, theoretically. So please do go read it out. That is, I think, clearly explained in the editorial. Also, you can go and check that out. Okay. So, often that was all for this particular video. I hope I've covered every part of it, so that even a beginner will be now they will know at least what they have to do next. Okay, they have to take the solution. They have to take a pen and paper, trace it out. First of all, be very clear with this class. Okay, the DSU class. Once you're clear with this particular class, if you understand how this DSU works, only then go and see the existing function that you're given. Okay, and then start coding. So yeah, and that was all for this video. And obviously, before coding, trace out the case, like see this, trace out and understand what is happening, why the DSU case is needed here, why the DSU is even needed here. Without DSU, why it will be difficult, and why it will not be optimal without a DSU. Okay, try to know this part and then solve the solution. So yeah, Farhan, that was all for this particular video. I tried my best to show whatever is possible. Okay, I tried my best. If you have any questions, please do let me know. And obviously, if you learn anything new, if you feel the quality of this content is really good, please subscribe to the channel. This really gives a lot of motivation to continue further. I'm about to complete 150 days, and I'm also about to complete 1,000, questions on LeetCode. So your support means a lot to me, because see, I need a reason to code. That's why if I know that yeah, my course is helping someone, it is helping me as well as helping someone, then obviously it will give me reason to code. Obviously, see, there are many people who can afford paid courses, but there are many who cannot. So for those people, I want to. That's why I'm creating videos for them basically. Okay, so that they get a free content where they can really get some quality content to learn from on a daily basis. Obviously. So, Evan, that was all for this particular video. See you tomorrow. Thanks a lot.